this region, the Horn of Africa region, is always identified as the most impacted by climate change and will be in the near future.
East Africa has fallen in between the cracks a little bit. It's also sort of at a crossroads, geographically and scientifically speaking. It's influenced by the West African monsoon, but it's really on the edge, and in some ways it's really more between and subject to the vagaries of both the West African monsoon and the Asian monsoon. The inflow to the Asian monsoon is this enormous atmospheric jet that flows along the coast of Somalia, and it's not really associated typically with African climate and weather, but because it's part of the Asian monsoon system, but it's very important for this region and relatively understudied.
In terms of the ocean atmosphere dynamics of the region, Djibouti is in a really exciting place. It's right at the dividing line between two major climate regimes, one in which it's wet in one season, one in which it's wet in the other season. So the reality is that there could be major changes in a region to the south of Djibouti or into the north of Djibouti that don't really reflect what's going on in Djibouti. So it's right in a very strong gradient, if you will. It's a dipole where there are changes to the north and changes to the south. And what happens in Djibouti is going to be really sensitive to that dipole moving north and south.
As you know, Djibouti has been dependent on the groundwater resources for a long time, but the government is now committed to develop surface waters. So therefore, we need to address the issue of how much it will be decreasing from now and in 10 or 50 years after.
A lot of people probably think that we understand everything about the atmosphere and the Earth as they are now, and we just need to know what will happen in the future. But really, especially for the tropics, there's a lot that we don't understand about just the fundamental fluid dynamics of the tropical atmosphere. We don't really know the dominant modes of variability, why and when it rains, where and when it rains.
So these models are very general, and their resolution is very low, very, very low. When you apply these global models, the resolution is so low that 1 pixel extent is 250 kilometers, and this is almost the 100% of the Republic of Djibouti.
I reached a rather startling conclusion in a paper that I wrote with Steve Sherwood in 2010. And in that paper we reached the conclusion that in the limit of a very strong warming, 100 years or so of dedicated burning of fossil fuels, that large parts of the world, namely in the tropics and subtropics, that they would become uninhabitable. And the effort here is an outgrowth of that. It's saying let's do really world-class, high-resolution, the best modeling that we can possibly do, modeling that we do for interacting with stakeholders and providing the best information we can in the U.S. Let's take that best-in-class science and apply it to an area that is understudied and doesn't have the resources to do it themselves.